All right, let's talk trackside warning detectors. Here's the good news about this. If you can read, this won't be an issue for you. Okay? Because we're going to talk about the procedures when you deal with a trackside warning detector, but all the procedures are written down right there in black and white for you to look at. This will be in your system special instructions. Let's turn to that. Turn to item 8 in your system special instructions. Item 8. Everything in your SSI is broken down by items. Item 8. If you find it and get a page number, just yell it out.
I think it's page 16.
Okay, is item 8 say trackside warning detectors? Not 8A, 8B, and 8B and all that.
Yeah, right here. It's page 13.
Trackside warning detectors. Are you in the right tab? Nope.
12.
That might help.
Page 13, SSI. Item 8,
That's where it went.
trackside warning detectors.
It's so hard.
Everybody's there now. Now, as you are fully aware of, technology is king, right? This is a technologically advanced society we live in. And the railroads are no different. They've got all the modern technology that anybody else has. And I'm telling you, there's some very high-tech stuff on the railroad. I've told you a little bit about how these detectors work, and they can inspect individual axles at 70 miles an hour, tell you the exact axle, what side, what's wrong with it. Okay, so technology is a good thing. It used to be, before all this stuff was invented. Remember when we had 5 people on the train? They had the cabooses and all that. It used to be every time a train came to a stop, for whatever reason, maybe it was to meet another train, maybe it was at a signal, or any reason at all, if that train stopped, there was instantly 2 people on the ground walking and inspecting that train, because they didn't have all this stuff back then, right? So this alleviated a lot of that. Even when I hired out, I originally hired out on the Southern Pacific Railroad, and they later, merged with the UP. Even as early as I hired out, they had all this stuff for, they've had it for years. They still had a rule to where every time the train stopped, we had to get off and start walking. It was like, well, that's the way we've always done it. So they just never changed. Luckily, the UP didn't do that. So trackside warning detectors. Here we go. Now you don't have to get all excited about all this information. I'm going to point out the information that's going to be important to you. And then what's, not to say that everything doesn't have a purpose, but for our purposes, I'm going to point out the things that I need for you to know, okay? All right, so it comes from the System Special Instructions, trackside warning devices. And this is a good one to start with right here. Brewski.
Trackside warning devices inspect passing trains for defects or monitor for unusual trackside conditions that could adversely affect the safe and efficient movement of trains. Examples of such devices include detection of the following conditions: overheated journal bearings, hot wheels, dragging equipment high, wide, or shifted loads, high water, earth, and rock slide fence.
So these are the type of detectors that we have out there to do different things. Okay. This is good here. Individual subdivision, special instructions. Individual subdivision, special instructions. You know what that is? I've told you once, but you might have not have caught it. That's the technical name of your timetable. Okay, a timetable. A timetable is actually called an individual subdivision special instruction. Okay. They identify the following: the location of the detector and the type of detector. Remember, I told you your timetable tells you everything you need to know about your territory. It tells you where all the detectors are by milepost location. It tells you what kind of detector it is. It tells you if the detector talks to you or not. It tells you what direction that detector inspects, like only westbound trains or only eastbound. Tells you all that, okay? Detector radio message. This is the way it works, and this is worthy of highlighting too. Okay, you're going down the rail, and you go over a detector. Here's what happens if you have a defect on your train. You just started over the detector. If it detects a defect, it's going to say, you have a defect. All right? And it comes over the radio channels. They're tuned to the same frequency as the channel for the subdivision. Okay? So if you hear the words, you have a defect, you have to immediately slow down to less than 30 miles an hour. Okay, using good train handling. And what that means is don't get overly excited and think you got to really rat down on it. Just slow down to 30. Okay. And then after the train passes the detector, a radio message will be transmitted. So if this is my detector right here, when I roll over it, it starts inspecting. And it will usually give you a greeting. As soon as you hit it, it'll say detector milepost 185, and that's it. So you're going over the detector now. If it notices a defect, it's going to say you have a defect. It's not going to tell you what the defect is because it's still inspecting the train. As soon as you hear you have a defect, slow down to less than 30. Now, once you clear off of the detector, right, then it will spit out the information for you. Okay? You have a defect. Axle 1, 3, 2, right side, hot box. That's the way it'll give it to you. Okay? Let me pick that. Oh, right here. This is another good thing. Approaching a detector. Do you remember me talking a little bit, and actually you took a quiz on it, a little bit about mandatory directives? And there's certain times to where that's not a good idea to be copying and transmitting mandatory directives. This is another one of those times. Why? You're not supposed to make communications within 150 feet of a detector unless it's an emergency. Okay? So if you're about to go over a detector and the train dispatcher says, yeah, NARS 1, 2, 3, 4, I got a speed restriction for you, right? Just get on there and tell them, yeah, dispatcher, we're getting ready to go over this detector. I'll call you back in a minute. Because you can't be doing that. And not necessarily because it's a critical time and all this, but really more importantly, if that detector starts talking while the dispatcher is going to give you that stuff, the detector is going to knock everybody out anyway. So you're not going to get the information anyway. You know? So just wait till you're off the detector. Yes, sir.
So two of these things can't talk over the radio at the same time?
No.
No.
You know, you can't have, nobody can talk over the same freak at the same time. Right. So one's gonna overpower the other. Whoever's got the strongest signal, right? And then the other guy's gonna get cut short. And that's what a detector does. When it starts talking, that's what you're gonna hear. Go ahead.
I don't even know what I wanted to say.
Well, the big takeaway from this right here, no communication when you're approaching 150 feet toward the detector, okay? You have to have your radios tuned in to the appropriate channel. For the time, you know, the timetable tells you the channel for that subdivision. So that's where everybody is operating on. Detector message and crew actions, right here. And you can see it in your book. You start seeing some tables come up, okay? We're going to get into these tables. Use these tables to determine what your crew actions are depending on the defects you get. Okay, so the book tells you exactly what you need to do. You just need to hear what defect it is. Okay? This is very important to you right here. This note. We have 5A detectors and 5B detectors. Okay? And in some cases 5C. But 5A and 5B. Here's the difference. If you have a detector that's labeled as a 5A detector, that detector protects something. It protects maybe a bridge, a tunnel, or something like that that you could mess up with your train if there's a problem with your train. You understand what I'm saying? So those detectors, you can just go ahead and figure that the restrictions for those 5A detectors are going to be a little more stringent than a 5B detector. A 5B detector is a detector that's looking for something wrong with your train. Hot box, dragging equipment, all these little things that could go wrong, but it's of no consequence to a structure up ahead. Okay? 5A, 5B. Yes, sir.
So 5A would be like a high access, or what do they call them, high load detectors? Or
High load, shifted load
shifted
detectors.
load? Okay.
Yeah, all those things. Think about it. If I've got a shifted load by 2 or 3 feet, most of these tunnels only give you like a foot and a half clearance, right? So you could cause some heavy duty damage to a tunnel or something like that. That's why 5A detectors are more stringent, okay? And you're going to notice that in the crew actions. That's why I'm kind of covering that now. So let's get into the different types of messages you'll get. Now look at the top here, Table 1, 8C, non-alarm message. Basically means it's not necessarily giving you a specific defect. Okay? What kind of detector is it? Non-alarm. What's the message that it's giving you? What's the train crew action for that message? And any additional instructions. Okay? So let's look at this one. Type of detector, 5A or 5B, it doesn't matter, right? You know where the detectors are located they're in your timetable. That is an excerpt from a timetable. You'll find detector information in item 5 of your timetable. We'll do that next week. Okay? But you can see 5A detectors, 5B, and in this case, 5C. Those are high water detectors. Go ahead.
So like those slide detectors, would that be a 5C?
Probably. Yeah. All right. So 5A or 5B,
When you hear a warning,
these have
you
built-in
must be
videos
prepared
in them.
properly carrying out orders. A sad statistic. In a recent 4-month period, 5 derailments were caused by improper compliance to detector warnings. So, what are your responsibilities as you pass a detector? You must be alert. Monitor the radio for possible messages indicating defects as well as the final detector message. Avoid radio transmissions until the detector inspection has been completed.
All right, 5A or 5B, what's the defect? Detector announces no defects or maintenance required. Okay? And most of the time, that's what you're going to get, right? Unless you're one of the most unluckiest guys on the planet, you know. It inspects your train, no defects, that's what it tells you. Well, what do we got to do for that? Nothing. Just keep going, right? Now, if it does say maintenance required, you might want to let the dispatcher know it said that. Okay? So if you can read these tables, you won't have any problems with detectors. And another thing, you'll do this every day out there as a conductor. So you'll learn these tables. You'll just kind of start knowing by heart what to do. Okay?
Now we're going to review the various messages that a detector sends.
BNSF detector milepost 177.2 no defects. Repeat, no defects. Total axles 27. BNSF detector out.
If the detector signal is no defects, the train can proceed with no action required. It is important, however, to record the axle count when it is given by the detector for use as verification on your next pass and report from a detector.
And I told y'all this the other day about the axle count information and how you have to compare that to your train list. And if it's wrong, you got to figure it out. Okay, a 5A detector or 5B, now you're getting into something that's going to have different requirements. 5A detector, integrity failure, or B. Integrity failure basically means it's inspecting your train, but something's going on to where it can't, the computer system, can't decide whether or not this is a complete inspection. Or maybe a little piece of something happening, or it just didn't feel like it made a complete inspection, right? So you get off of it, it's going to say integrity failure. Okay? Now, 2 different actions. If I'm on a 5A detector, what do I have to do? Anybody?
Make a walk inspection on both sides of the entire chain before reaching bridge tunnel or structure.
So if I'm going over a 5A detector and I get an integrity failure, I'm required to stop my train and walk the entire train, both sides, and inspect it. What about if it's a B? No harm, no foul, right? But you see the importance of a 5A and a 5B a little bit from this, because here's what they're saying. It said integrity failure, right? Maybe there's nothing wrong with your train, right? But since we're going over this kind of detector, we're not 100% sure, are we? So we're not taking any chances. We're going to stop and inspect both sides of the train. Why? Because this detector is protecting something up ahead. So that's kind of the idea behind the 5A requirements and 5B requirements. Okay? You'll have this class next week. This talks about some information from hazmat, hazardous materials. You know, we carry a lot of hazmat cars in our trains. Ross, why don't you take off with this one?
When a key train is stopped by a trackside or wayside warning detector, the indicated car, hazmat or not, must be set out. When a freight car or a freight train other than a key train is stopped by a trackside, wayside warning device, and the indicated axle is on a loaded place card, non-intermodal car, it must be set out.
Now, I have to kind of explain this to you a little bit before you can even understand it, right? Because you haven't had a hazmat class. So I'm going to give you the down and dirty of what they're saying here. We carry hazmat materials on trains. And you can see the different types of placards we use. It goes along with the different types of chemicals and all that. Okay? If I am carrying enough of a certain kind of chemical in my train, that could make me a key train. Key train means the dispatcher handles you a little bit differently. Your max speed is reduced to 50 miles an hour. So it's a little bit more precautions if I'm a key train. Okay? For example, if I have 20 tank cars full of flammable gas throughout my train, if I have 20 loads, that would make me a key train. Okay? So you got that situation. Now, another train might be just a normal manifest train, like they were humping the other day, possibly. Just mixed cars. You got grain cars, hopper cars, maybe a few tank cars here and there. Mixed up manifest. I don't have enough chemicals of a certain type to be called a key train. I still got hazmat in my train, but I don't have enough of these chemicals to be called a key train. So that's another scenario. Here's what they're saying here. If I am on one of these key trains and I go over a detector and it says axle 162 right side hot bearing, right? So I get off and I walk back to axle 162 and I do my checks. There's no hot bearing, and you'll get that a lot too. There's no hot bearing back here. Okay? Because you're on a key train, you still have to set that car out, whether it's hot or not, if the detector got you. Okay? And it doesn't matter if it's one of those loads of gas or a load of lumber. It still has to come out of the train. Now, conversely, if I'm on that regular manifest train, I go over the detector. I'm not a key train. I got a little hazmat. I'm not a key train. I go over the detector. It says axle 162 right side axle hot, or bearing hot. I go back to 162, do all my checks. No, it's not hot, right? If that axle just happens to be on one of those hazmat cars I got in my train, that car has to come out, regardless, whether it's hot or not. Does that make sense to you? Okay. Now, if I'm on my regular manifest train and that axle fell on a load of lumber, I wouldn't have to set it out. Okay?
Now, really quick, back to the whole location of the detectors on
Mhm.
the time, like, you would find that in the timetable, their location?
Yes.
Where, what would they be, what
They're,
character?
they're in item 5.
Okay,
Item
so-
5 of your timetable.
Oh, okay, no.
So, keep turning the pages here. Keep turning the pages. Item 5. I don't have my glasses. I
Oh,
can't
this
see
is, I
anything.
think I'm in 7, but, 4.
Well, yeah, they go in order. Item 5.
Yeah, it goes.
What's that say? B.
It must be cut out, it's probably right here. Yeah, and then, so that would tell you each, okay.
Let me get my glasses, you're making me.
Yeah, because
Yeah,
this
no.
is 6 and that's cut off.
Yeah,
I
it's-
want to say that's 5.
That is 5.
Where's,
It just got cut off in this
Yeah,
printer.
that's 7,
Yep, and then
Yeah.
6. and then
6?
5.
Yeah, this is it right here.
Okay.
Okay, so these are 5A detectors,
Mhm.
right? These are 5B detectors,
Oh, okay.
and these are 5C detectors,
Gotcha.
okay?
Yeah. Here.
All right,
BNSF detector milepost 202.5 integrity failure. BNSF detector milepost 202.5 integrity failure. BNSF detector out.
This means the detector is unable to make a complete inspection. You must first check in the individual subdivision special instructions to see if this detector protects a bridge, tunnel, or structure. If it does, stop and inspect the train. Otherwise, the train may then proceed. In any case, the dispatcher must be notified. Remember, you're required to be familiar with the individual subdivision special instructions.
When a failed equipment detector reports system failure, integrity failure, or train too slow, on a key train, the train may proceed while being closely observed and not exceeding 30 miles per hour for 30 miles, unless inspected by another detector or delivered to a terminal where mechanical inspection will be made. If after 30 miles the train has not passed another detector or has not been delivered to a terminal for mechanical inspection, a roll-by inspection must be made at a speed not exceeding 5 miles per hour. If a crew change occurs before the 30 miles have been completed, or the roll-by inspection has been performed, the new crew must be advised of the required inspection.
okay, 5A or 5B, train too slow. Action, proceed. Everybody sees that. Train too slow, what that could be from is, they say if you get below 10 miles an hour going over a detector, you could get this message. Okay. So most of your engineers are going to try to avoid that if they can. And even when, let's say you come to a big metro area like Kansas City, well, if it's busy here in Kansas City, you could start kind of getting in line still out in the country because the trains are stacking up. Well, you might get stopped for a while. And engineers will always kind of try to watch where they stop. They try to stop where they don't block crossings, and they don't want to stop on top of a detector because when they get started again, they might get a train too slow or an integrity failure, right? So they try to keep tabs on stuff like that when they stop.
BNSF detector milepost 234.2 train too slow. BNSF detector milepost 234.2 train too slow. BNSF detector out.
This means that the train is not moving fast enough for the detector to make a full and complete inspection. Like integrity failure, the train too slow signal means the train may proceed unless other messages require inspection, or the individual subdivision special instructions indicate that this detector protects a bridge, tunnel, or structure.
All right, so now we're going to start getting into some different types of alarm messages right here. So these messages that you might get off of this could be actual defects that it detects.